Hello everyone, welcome back to the latest lecture session. So in the last session I guess we were discussing alkalinity and its relevance, and alkalinity, as you know, is nothing but acid neutralizing capacity, right? So it will restrict or try to resist rather the decrease in pH. It's not the resisting change in pH, it's resisting decrease in pH. Change in pH resistance, that's more or less buffer or buffer capacity. Here, alkalinity, we are just trying to understand how the solution can resist the change in, not change in, decrease in pH, right? In that context, we were about to look at an example. So let's see what it is that we have out here. So at equilibrium, again keep in mind that we are always concerned with, at least in this class, we are concerned with the state at equilibrium or the situation at equilibrium. So we have a sample that has a pH of 10 and 32 milligram per liter of CO3 2 minus, and alkalinity of the water in the following units. We want it obviously in equivalents per liter and also as milligrams per liter as CaCO3. Okay, let's get this done or look at it. Again, this, as we mentioned, plays a critical role in keeping the pH relatively neutral in ocean waters, right? That's something that we discussed. Without alkalinity, it's going to decrease pretty much. Here we are just looking at a theoretical example, and the reason for this example more or less is that we want to keep you guys interested, or a major fraction of the people or students interested. Depending on your feedback, I guess we will change as we go along. Okay, alkalinity, we need to list all the bases. The bases are, I guess, OH minus and HCO3 minus and CO3 2 minus, right? But because CO3 2 minus can neutralize 2 protons, we are going to have 2 here and minus H plus. So from pH 10 you can calculate OH minus and H plus, and you already have the concentration of CO3 2 minus, right? But you need concentration of HCO3 minus to be able to calculate alkalinity. How do you get that? Obviously these are molar units, right? And with 2 we are obviously getting the units in terms of equivalents per liter, right? That's what we are doing here, equivalents in terms of what do we say, neutralizing a H plus. So how do we get HCO3 minus? You know the relationship between protonated form and deprotonated form of the acid, that you can use that, or we know the equilibrium constant for that particular reaction. I think it's 10 power minus 10.3, right? Because pKa2 is 10.3 for the carbonate system, right? So let's move on and understand, or just get this done. So obviously we want to calculate the molar units. So 32 milligrams per liter, 32 into 10 power minus 3 grams of CO3 2 minus per liter of water, right, into or rather 1 mole per 60 grams of CO3 2 minus. So the units of grams of CO3 2 minus, grams of CO3 2 minus cancel out, and looks like we are left with 0.53 millimolar molar units, pardon me, right? So for the next step is to calculate HCO3 minus. So as we discussed, we have this acid dissociation reaction, right? And we have the Ka for this, or equilibrium constant for this reaction, and from that, what is Ka? Obviously the product of the activity, which we are assuming to be equal to the concentration here, product of the concentration of the products, right, divided by the concentration of the reactants, right, raised to their stoichiometric coefficients, but all the stoichiometric coefficients here are 1. So here we have Ka equal to 10 power minus 3. So H plus, CO3 2 minus. Now you can calculate HCO3 minus, right? So it looks like we end up with 10 power minus 2.97 molar units, I guess, right? So let's move on. So total alkalinity, this is what we know it is to be, and let's plug in the relevant values, and looks like we get it in terms of 2.2 milliequivalents per liter, right? Keep in mind that the units when we use the equation in this form are always going to be equivalents per liter. and the units, you know, square brackets indicate molar units, right. But obviously, you know, we are trying to get the equivalent in terms of H plus, that is why we have the prefix 2 here, right. So, that is the reason why we end up with equivalents per liter. But I believe the question also asks you to, you know, change the units into, I believe, what now, as CaCO3 to express them in terms of as CaCO3, right. So, again you can look at the equivalents per what do we say, unit weight, I guess. Molecular weight, we know 100 grams CaCO3, because both are what is it, divalent Ca2 plus and CO3 2 minus, Z is equal to 2, and thus equivalent weight, I guess, is 100 by, or molecular weight by Z, that is going to be equal to 50 grams, right. So, 1 equivalent per 50 grams, I guess. So, let us go ahead and calculate that. So, we have 2.246 milli equivalents into 50 grams of CaCO3 per equivalent, that is what we have out here. And so, the units of equivalents cancel out, we are left with grams of CaCO3 as the unit. So, we end up with 112.3 milligrams per liter as CaCO3, right. And let us move on and look at, you know, move on to the next topic. Okay, here we have water quality parameters. So, until now, I guess we tried to understand what the system will be out there in nature, let us say, given different conditions, mostly depending upon acid and base reactions and phase change, right. Now, you know, again this aspect is related to more about awareness about what is out there, and why, I guess, more importantly, a concerned but inherently selfish person like you and me, what do we say, need to spare the time to go through this, right. So, let us look at what we are going to have. So, we are going to look at water quality parameters, the typical parameters. Again, let us say you are buying a water purification system, you want to know what kind that you want to purchase. Obviously, you can what do we say, fall for what the salesman is going to sell you, right, or you can make a more informed decision. And more importantly, let us say, again, as I mentioned or keep harping throughout this class, you know, once you become what do we say, a decision maker, let us say, right, or you know, a particular wheel in a huge machine now, but you know, you will still be able to, I guess, hopefully, you know, change the course of or alter the course of that machine, you know, depending upon your efforts, let us say. So, in that context, we want to create greater awareness among you people, or the what do we say, future citizens, so that again you can lead to a better what do we say, society or country for all of us. So, let us you know, get this done. So, what are we going to look at? Water quality parameters and major ions in water and natural organic matter, right. So, again, why, I guess, let us look at what we have. So, top 10 causes of death, again this is for the concerned but selfish citizen, right. Why do I need to care, right. Okay, top 10 causes of deaths. Here keep in mind that we are looking at all ages, right, and I guess the data was collected over this period now. So, here we have or rather I have the what do we say, data sorted in descending order, and keep in mind this is the source from Indian census. So, what do we have out here? Cardiovascular diseases, yes, you know, we have remarkable what do we say, number of deaths due to this particular cause, again more than a fraction, not more, I guess, slightly less than a fraction. Again this has to do with too much carbohydrates being taken in, no exercise or less to no exercise, and obviously air pollution, right, stress. Well, I guess the reasons are never ending, but typically again carbohydrates, too much carbohydrates, no exercise, air pollution and stress, let us see, right. Cardiovascular diseases, that is something that you would expect. Again this you know, ill defined, you know, or those deaths for which you know you could not what do we say, ascribe any particular reason or such. All other symptoms, signs and abnormal clinical and laboratory findings. Again this could be due to, you know, again typically water pollution, let us say, and air pollution, mostly due to water pollution. But again keep in mind that we are you know, stretching what do we say, facts here, because we are only presuming or trying to draw some conclusions right, based on the very little data that we have out here. Again, ill defined, but I do remember seeing that the number of deaths due to such or that can be ascribed to this particular what do we say set of or this description has been increasing. Again, that is more or less with respect to pollution, that is what I would believe. Then respiratory diseases, again air pollution, it either exacerbates what do we say the relevant issues with respect to the people suffering from asthma. That is one general aspect, but there are many other what do we say ways, I guess, reasons that can lead to deaths due to respiratory diseases, right. But air pollution plays a critical role, right, remarkably critical role. And then your tumors, cancers and so on, again this has also been increasing, and again air and water pollution again plays a role here, right. Perinatal conditions, I guess 5.6, we are not really looking at that in great detail now. And more importantly, in the context of this particular section of the course, we have diarrheal diseases, right. Again 5%, I guess 5% of the total deaths, right, in in India between this 3 or 4 year period is due to diarrheal diseases, right. Again diarrheal diseases, certainly only reason is you have what do we say the relevant pathogens in water, and the people are what do we say taking or drinking this what do we say water now. Again your water, why am I highlighting this? Well, I guess it is pretty easy to what do we say understand why. One reason, okay, I thought okay, here we have diarrheal diseases. Keep in mind here we are talking about the top 10 cause, and this is I guess more or less tied with 5th, if I may say so. And the reason I am laying stress upon this is this is easily preventable, right, remarkably easy. Depending on what do we say where you are, you can just boil the water to the right temperature, and that is good enough. But again, in a country like India, you have vast stretches or vast what do we say number of, not vast number of, vast fraction of the population that is pretty poor now, and certainly illiterate, right, and that they are what do we say a double whammy, if I may say so, right, and that is going to lead to a considerable number of deaths due to a easily preventable cause. That is the reason that I am highlighting this. Again, keep in mind that we are talking about easily preventable. These they require lifestyle changes, to bring down air pollution, water pollution, remarkable levels of systematic changes, right, with respect to regulation, enforcement and capital costs and so on and so forth. Again, keep in mind that diarrheal disease much higher than, again digestive diseases, yes, some water pollution, but we can't really be sure, is much higher than, not much higher than, relatively higher than unintentional injuries other than motor vehicle accidents. I guess I saw suicide too somewhere, that is almost the top 10 or I guess 12th or so. That is something to keep in concern, Hakuna Matata, I guess. Unintentional injuries other than motor vehicle accidents, respiratory infections, again air pollution, right, tuberculosis, yes, that is something that, but this has been coming down in India, if I may say so, and all of the remaining causes just 22%, right. Again unintentional injuries, right, and even keep in mind that diarrheal diseases, number of deaths due to diarrheal diseases are greater than the motor vehicle accidents, intentional ones, that is not even making the top 10. As you can see, most of these are either lifestyle with respect to cardiovascular diseases, or all these diseases have one common or have one underlying aspect, that is again pollution now, right. So again keep in mind that we do not have deaths due to terrorism in the top 10, right. We do not have deaths due to war. Again keep in mind this is India, we are not at war or have not been recently been at war. Although war catastrophic event, you would always want to take precautions such that in the event of a war you are not going to face a catastrophe. But again keep in mind we are living with what do we say terrorism, and people's emotions are remarkably what do we say excited, if I may put it what do we say not bluntly though, right, if I may use that term, right, in terms of elections or during elections and such. But do we ever come across what do we say political parties or such who say, okay, the number of what do we say cardiovascular diseases, the number of diarrheal diseases is remarkably high, it's not acceptable to me, and I'm going to put in money and try to take care of this. Again, we are talking about either a quarter or a 5% population, not population I guess, of the deaths in India being due to cardiovascular diseases and the other diseases relevant to what is it now, water and air pollution. Again, that is something for you to think about, think of how much money we put in, but the number of what do we say causes that in my opinion have equal if not more what do we say priority I guess, right, or need greater emphasis. But when we look at the top 10 causes of deaths between age 1 and 4, infants now, just born, again keep in mind same time period, where is diarrheal disease, where do we see it almost jumps to, well let me not say 20%, 18%, right. It is almost the first, right, first one is pneumonia, right, again with respect to air pollution, diarrheal diseases, right. So, infants, their bodies are just developing, getting used to the world, different systems, pathogens and such. So, they are relatively always vulnerable, pardon me. And what do we have? We have, what is it now, 20% of infant deaths, almost 20%, being due to an easily preventable disease, diarrheal diseases, right. So, again I am just trying to emphasize why we, you or anyone out there needs to pay attention to this, right. And then pneumonia again, right, and what else do we have just for the sake of looking at it. So, injuries I guess yes, depending on where you live, non-communicable diseases, malaria yes, fever of unknown origin, but again keep in mind here we are looking at single digits here I guess, congenital anomalies, infectious and parasitic diseases, right, meningitis and so on and so forth. But again what jump out at you, pneumonia and diarrheal disease, again diarrheal disease 20%. So, you see the disproportionate effect I guess, almost 40% of the deaths are due to pneumonia and diarrheal diseases, right. And even if you look at age groups, okay, top 10 causes cause 91% deaths under the age group, okay. So, that is something to note here. All other remaining causes just what do we say now, 9%. So, as you see top 10 causes lead to 91% of the deaths under the age group or between the age group 1 to 4. Top 3 causes, namely pneumonia, diarrheal disease and injuries are responsible I guess obviously for 50%. Let me not spend more time on this. Again, when we now look at 5 to 14, the bodies are have relatively developed but are still developing, and you still see that diarrheal diseases still lead to almost 12% or 11% death. But again here we still have considerable deaths due to unintentional injuries, let us say I guess. Again we are now still looking at diarrheal disease being responsible for the death of 10% of your future workforce, future citizens, right. And again this is a remarkably preventable diseases. Again here we do not have way too many other what we say causes of deaths which are due to water pollution and air pollution, because they typically act longer, and we saw that in the context of, not in the context I guess, for all ages I guess, right. Here we see the more pronounced effect of what do we say long term exposure to air pollution and water pollution, and here obviously we have short term, not short term, acute effects mostly due to diarrheal diseases, right. So, young age diarrheal diseases, but as you grow older obviously water pollution and air pollution are the killer. So, in this context let us understand again what are the general what do we say parameters that we or you are concerned about, and maybe why, and maybe what you can do I guess, right. We will not spend too much technical detail, but enough to win that discussion that you want or you will have with your neighbor out there, right. Again, critical need to supply potable drinking water. As I mentioned earlier, diarrheal disease is the second leading cause of death in children under 5-year-olds. The major issue that not issue, the reason that I emphasize it is because it is easily preventable and even treatable I guess. So, double whammy here, lack of access to potable what do we say water, and then lack of access to medical care, right, or lack of access to affordable medical care. Yes, let us move on. A significant can be, okay, we discussed this, through adequate sanitation and hygiene, yes, again related to both awareness and infrastructure, right. And again keep in mind that diarrhea, the other aspect that strikes you is that it's not just one of the leading causes of death, it's a leading cause of malnutrition in children under 5-year-old. So what does that lead to? It leads to stunted growth, malnutrition, and right at this period the brains are developing now, the bodies and brains. So but this development, I guess, that they are going to lose out on, that's going to stay with them for their life, right. That's going to have a long term impact too. That's something to keep in mind. And obviously I guess this is something that everyone knows, but just to reiterate, diarrhea is a symptom of an infection in the intestinal tract, which can be caused by a variety of bacterial, viral and parasitic organisms, again different pathogens. Infection is spread through contaminated food or drinking water, again mostly it is drinking water in India, or from person to person, or as a result of pure hygiene, again sewage, not washing hands properly and so on and so forth. But again these are the aspects, I guess, right. But typically in India, drinking water has great correlation with what do we say, diarrheal cases, I guess, right. But again easily preventable, both through, I guess, a combination of awareness and some, what do we say, sanitation now, right. Let us move on. Sources of drinking water. Let us say, where do you get your drinking water from? Let us say that depends on where you are. If you are near what do we say, surface water source, typically let us say a river, typically the river water is pumped to different localities out there. And if you are way far off from a perennial source of what do we say, surface water, you are going to use groundwater. But the issue with groundwater, you are overdrawing it, and to the extent that whole cities are subsiding at some places, but that is a story for a different session, I guess. Source of drinking water, groundwater. So we have shallow wells, deep wells. Shallow wells typically from dug by private what do we say, people or citizens. Deep wells typically dug by municipalities, let us say, right. Here we are talking about 200, 300, 400 feet or 400 feet rather, right. Surface water, obviously. Let us move on. And what is the issue now, right? Constant composition. And why is that? Groundwater, let us say, why is it relatively of constant composition now? Let us say there is rain falling on the land, and all this runoff, right, of the rainwater is going to end up in some surface water body, right. So this runoff can what do we say, have different kinds of pollutants, and that is going to affect the what do we say, characteristics of the surface water considerably. But groundwater, how does the water reach the groundwater now, or the aquifer? So it has to permeate through the layers of this particular aquifer or soil, let us say, and all the soil acts as a filter, filter, I guess. So that is the reason why you have constant composition, and obviously variable composition depends very much on the season and different kinds of industries out there and so on and so forth. But one aspect is obviously in contact with different minerals out here. So high mineral content, low mineral content, low turbidity. Turbidity as in sense that how many, it is a measure of how many suspended particles are out there, right. Again gives you an idea about how polluted it is or how fit it is for drinking water, because it is obviously the water reaches the groundwater after if I can use the term filtration by the soil, obviously low turbidity, surface water certainly high turbidity, low colored. So again here we are coming across some terms, dissolved oxygen, right. DO is dissolved oxygen, it is remarkably critical, obviously because the groundwater beneath the surface does not have access to atmospheric oxygen, there can't be any phase change, right. So that is why low or no dissolved oxygen, but there will certainly be a non insignificant amount of dissolved oxygen in the surface waters, but we will see why, I guess. Carbon dioxide H2S may be present, low hardness, high hardness and so on and so forth. Again major aspects are constant composition, variable composition, low DO present, and high and low mineral content, I guess. Again just giving you an idea about it, and that is one reason why we are very much dependent upon groundwater, as in we think that it is typically good enough to what do we say, drink, with little to no treatment. But what we have been experiencing is an exponential growth in population, right, an explosion in population growth too. So now we have overdrawn the groundwater such that most areas are under water stress. So we will come back to that. So again, that is the reason why obviously we are looking at groundwater, but some scientific background. But where is the pollution coming from? For example, you would have read about people trying to clean up, or the government trying to clean up or improve the quality of rivers, especially Ganga, right? And how are they doing that? They are building different sewage treatment plants. But sewage treatment plants, obviously they need a piped sewerage network to carry the sewerage or waste to the sewage treatment plant. So for that you need to know the source, point sources, I guess. Okay, so again we will come back to this. So what are different point sources of pollution? Municipal wastewater, industrial wastewater, wastewater from industries, municipal wastewater and tributaries, let us see, right? And non-point sources, so these you can treat, you can identify them, errant industries, obviously sewage, if it's piped you can, right, you can treat this relatively more easily if you can identify those sources. But the issue with non-point sources, right, is untreated sewage, where you have little to no drainage network and such, and it just joins different drains or nalas, and that ends up in the river, and you are going to have untreated river full of untreated or partially treated sewage. For this, I guess the issues are long term. You need to have a proper sewerage network, and that requires a lot of capital, right? That is something to keep in mind. And obviously runoff from agricultural land, from atmosphere during rainfall, let us say urban and suburban runoff as in, let us say we here in this road that I live in, right, we have different shops, different people throwing their waste onto the road, and we also have 3 bike mechanics right beside each other, 1 car wash and so on and so forth. Do they have piped wastewater? Access to piped wastewater, or sewerage network? No, they dump all their waste on the ground. And here is the Ganga canal, and whenever it rains, what is going to happen? All this pollution is going to go and reach the Ganga canal, and that is going to be transported downstream to other people, right. So these are the issues that we have, and non-point sources groundwater, but that is not of great importance now. So what are the issues that we have out here? Well defined, origin is easily measured, more constant. Well, the whole aspect is about that it is easier to treat and regulate. This is almost impossible or difficult to treat and regulate. So even though we are building a lot of sewage treatment plants, right, to be able to really bring about a change in the surface water, you need to be able to have a lot of capital investment and awareness with respect to dumping waste and such, right. So that is something to keep in mind. Even though we build a lot of STPs, we might not see a remarkable improvement in surface water quality unless we address the other issues too, right. And I guess I am out of time for today. So we will follow up with the aspects in the next class. We will look at what are the parameters, why it is relevant to you, and what are some of the sections or places in India which face a particularly distressing issue or such, right. So I guess with that, thanking you for your patience, I will end today's session.